Hello friends, welcome to my channel. Let's have a look at problem 2606. Find the substring with maximum cost. This is a newly appeared problem today. In this video, we're going to explain a treatment based on finding the largest consecutive subarray sum. So this problem actually is the same as finding the longest subarray sum for a numerical array. Here we are going to explain this connection and solve this problem using the simple dynamic programming technique here. Essentially, we are using the so-called Kadane algorithm. First, let's look at the problem statement. So we are given a string S and a string characters of distinct characters and an integer array called values of the same length as the character. So in other words, we have a string characters and we have values. So these two have the same length as an iterable, and the values actually corresponds to a value in the characters. So the cost of the substring is the sum of the values of each character in the string. The cost of an empty string is considered to be 0. So due to this assumption, the maximum cost for a substring in this problem must be at least 0, right? So the next paragraph explains the value of a character is defined as the following. So if the character appears in the string characters, then its value is the corresponding value in the values list, right? If it's not appeared, then assuming I is the index where the character occurs in the string characters, then its value is this is the second item. Now let's look at the first one. So if the character is not in the string, then its value is the corresponding position in the alphabet. So for example, A is 1 and B is 2 and Z is 26. And if the character is in the characters, then its value is the corresponding values in the corresponding index. So we are required to return the maximum cost among all substrings of the string S. So here are two examples. In example 2, so this is very special because these three unique characters occur in the characters and all their values are -1. Because we don't want to have negative values, so because the empty one have a score 0, so we just return 0. And in the first example, we know D has a value. This is very negative, right? And A has a value that is 1, because A does not appear in does not appear in characters. So its score is 1. So AA is a substring, so we get output 2. So the constraints for this problem are the following. Here, let's point out several of them. First, the length. The length can be up to 10 to the power 5. So this defines the problem set's upper bound. And the second one is important. S consists of lowercase English letters only, and the characters contains distinct lowercase English letters, right? So the last, this one is a consistent assumption. So with that said, we're ready to do the analysis. So for this problem, so the idea is that each character corresponds to a numerical value, right? So either coming from the score in the values or from the corresponding position in the alphabet. So this actually maps the string S to a numerical array, right? Then the task is in the problem is nothing but finding the largest subarray sum, which corresponds to the maximum cost of the substring, right? Then we just if we realize this connection or this point, we could use dynamic programming to solve this problem easily. So essentially, we will use the so-called Kadane algorithm. So with that said, I guess we are ready to do the coding. So the coding actually now is very straightforward. Let's see. Step 0. So get the map between the character and the corresponding value, right? So for this, we're going to use a dictionary. So this is for convenience of check. So then we're going to iterate, right? So let's see. We can do. There's many ways to do. Two ways to do this. We can iterate first over characters, and then we check remaining characters in the alphabet, or we can first check alphabet, then do a if clause. So now let's do this. So for character and value in zip, characters and values, and then this is the character and this corresponding value, right? And then what we are going to do is to do the following. So we are going to do this: the character equals value. So we didn't have update because this assumption. So characters consist of distinct lowercase English letters. So each key is unique, right? And then this covers all the characters from here. So also we need to check the alphabet so that for each of the 26 characters, we associate it with a score. So we can do first, we can get the A up to Z. So from string, import ASCII lowercase. So this is just so this ASCII lowercase is nothing but a string consisting A up to Z. But if you like, you can type by hand. So then what we're going to do, so for index and character in enumerate, ASCII lowercase. So here I'm going to start index from 1 because here we required that it's 1 indexed, right? And then what we want to do is a if clause. If character not in this characters, equivalency is not in D. So here I'm checking with D. This is for easy checkup, right? So if the character is not equal to D in D, so we're going to set its value to be the corresponding position in the alphabet. So this is the first step. So next, actually, we can do the map, right? We can map the string to the corresponding array, but it's not necessary. So let's directly do the DP, right? So here I'm going to write with some extra space, that is O of n, where n is the length of s. But this can be easily reduced to O of 1. So here let me write n equals the length of s, and then I'm going to use a DP table. So length is n, right? So here the interpretation is that, so this is the max cost for a substring, or this is the sum ending at index I, inclusive, right? So DP0 should be just nothing but a score, right? That is S0, the S0. And then we can initialize our result to be the max. So because it's at least 0 by the assumption of this problem, we use a max function and DP0, right? And then we can do the DP update. So for I in range 1 up to n-1, so we write n here, right? Then if DP I minus 1 is greater than 0, right? Then we can connect the previous sum with the current elements at index I. So we get dpi equals dpi minus 1 plus ds of I, right? And then otherwise, if dpi minus 1 is less than 0, then we can set dpi to be d of si, right? So now, after this if and else clause, we get the corresponding dpi. In other words, we get the maximum cost ending at index I. Then we can do a comparison, right? So basically, we update the result like this. And then what we are going to do is to do step 2, do the return. So we just need to return the result variable, right? In other words, the result is the max of these dpi's, right? Also max with respect to 0. So before we make any comments, let's first do a check. here, invalid syntax. Okay, if character not see here in D, right? We forgot this keyword. Yeah, it passes the first example. Now let's look at the generic case. Yeah, it passes all the cases decently fast. So here, let me make some comments. So first, if you want to really fill the connection with the longest subarray sum, so you can map the string to the array. Let's do this. D of y for y in S, right? You can print out this array. Let's just look at one example, right? Yeah, this is the ADAA, because A corresponds to 1 and D corresponds to 1000, negative 1000. So we have 1, negative 1000, and 1, 1. Right, but this is not necessary at all for this problem, right? Let's comment out. So this is one thing we want to comment. Another thing is that, so here, in order to fix the idea or make it more clearer, so we write using O of n space in this part. But this part can be easily reduced to O1, right? We just need to use a result variable and a running variable to get it done without using this. That's actually a very straightforward optimization. So with that said, I guess that's about it for this specific problem. And in this video, we transformed this problem to be a longest subarray sum problem, and then we solved it using dynamic programming. So I guess that's about it for this video. Thank you.